Let's solve by sketching a single parabola and factoring. So we have a decision to make. We can either throw everything to the right or to the left. I like a positive x squared, so let's throw everything to the left and see what happens. We have x squared is greater than, x squared minus 5x plus 6 is greater than 0. We threw everything over and there's nothing left on the right hand side. And now we're going to factor. So x times x is x squared. We have two negative signs. And what times what? Let's try 2 and 3. And it looks right. So if you're to draw this quadratic, we have 2 here, we have 3 here. It's going to be a happy face that opens up like this. And we're interested in when the quadratic is greater than 0. So greater than 0 means over here and over here. And we're going to have a hollow circle here because we have only we don't have an actual equal sign for this inequality. So the domain in which it is greater than 0 is x is less than 2 or x is greater than 3. You can even have a union symbol if you wanted to. So this here is our single parabola. Let's try B. Let's solve by graphing a parabola and a line. So we're going to focus on this parabola here. The first equation is y equals x squared, or y1 equals x squared. And we know how to do that. So when you go 1 unit to the right, it goes 1 unit up. You have 0, 0, and here we have 1, 1. And when you go 2 units to the right, it goes 1, 2, 3, 4 units up. So you can see this here is going to be 2, 4. And when you go 3 units to the right, you have 3, 9. So this is around 3, 9. So it's better to have graph paper, or perhaps we can use Desmos. But you can see that the parabola does something like this. This is kind of ugly, but you get the point. And now we want to draw the line. The line is y2 is equals to 5x minus 6. So minus 6 is the y-intercept. 1, 2, 3, 4, 5, 6. So this is negative 6 is where the line crosses. And this line is quite steep. When we go 1 unit to the right, it ends up going 5 up because the slope is 5 over 1. 1, 2, 3, 4, 5, way up here. So we're going to connect the line here. Let's change the color. Now from this point, which is at 1, negative 1, we're going to go 1 to the right, and we're going to go 5 up. 1, 2, 3, 4, 5. Aha! We hit right on over here. And when we go 1 to the right, we're going to go 5 up. You can see that we're hitting again the graph over here, right at these particular points. And of course, the parabola, this line continues on, whereas the green parabola, it curves above the line since the parabola grows faster than the actual line, which has a fixed slope. So the word solve means to find the x values. So even with this terrible drawing, we know that the solutions are x equals 2 and 3 are the critical points. And now we can focus on which is bigger than the other. The question is asking for the domain in which the parabola is greater than the line equation. And when is the green line above the red line? It's above the red line when x is less than 2, or when x is greater than 3. Exact same domain. So visually, you can draw two separate graphs, or in part A, you can simply focus on one equation, which I think is easier. So here we typed in the graphs, the two equations into Desmos. It's a little bit hard to see. Clearly the red graph is higher than the purple graph. As you zoom in, you can see that between 2 and 3, the purple graph is actually slightly above the red graph. Okay, now it's your turn.